And so there are 8 parent functions that you need to get down. The first one is what is known as the constant function, and that's just a horizontal line. So it's f of x equals, and that could be any value. It could be 5, it could be 4, it could be 3, it could be 2, anything. Okay? The identity function is just a line with a slope of 1 and a y-intercept of 0. Has the equation f of x equals x. Quadratic function, remember, is a parabola that opens up or down. Okay, and that equation is f of x equals x squared. Cubic function, f of x equals x cubed, looks like that you're given. It'll also look like this. Okay, so it could look that way. That's in the parent functions, but f of x equals x cubed, that is the way the graph looks. Let's look at the square root function. Square root function, f of x equals root x, and then the reciprocal function, f of x equals 1 over x. And then the last two, the absolute value function looks like a v. And then the greatest integer function, this is also called a step function. Okay, and this refers to stair steps. And basically, where something like this is used, is an example is your cell phone minutes. Okay, you know, when you do cell phone minutes, they round to the nearest minute. They don't say it's like 1 minute and 30 seconds. That's not what they charge you for, right? So if you talk for 1 minute and 30 seconds, what do they charge you for? They charge you, do they round up to 2 or do they only charge you 1? I'm thinking they might charge you only 1, but that would be something to check on. But that's one of the things, they never charge you a fractional part of a minute. And that's how these stair-step functions work, okay? Because there's nothing in between. It's whatever the whole numbers are. And so what we're going to do today is we're going to have, I call these monster problems in a way just because there's so much information that we have to go through. But let's go ahead and look at it. It says, describe the following characteristics of the graph of the parent function f of x equals root x. So we are finding the domain, the range, the intercepts, the symmetry, the continuity, the end behavior, and the intervals on which the graph is increasing or decreasing. This isn't tough stuff. What we're doing is we're putting together everything that we've reviewed since the start of the year into one problem. So what we're going to do here is we're going to go ahead and graph that on our graphing calculator, and we're just going to pick those off one by one. Okay? Like I said, it's not a difficult thing to go through and do. You can do all this. Okay? So we're going to graph f of x equals root x. And so in looking at that graph, and once again, if you didn't even have it graphed, you could actually turn back and look at page 45 at that sheet, or at that picture as well too, because that's got that. And so I need to determine the domain. So the domain is the set of what? X values, good. Okay, and so what, remember this is where I look left to right. What is the leftmost point on that graph for x? 0. Do I include 0 or not? Yes. So I'm going to use a bracket, remember? How far right does the graph go? Positive infinity. Good. So there you go. There's the domain. Now the range is up and down. Remember, that's our set of y values. So what is the lowest y value that is on that graph? 0. Do I include it? Yes. What is the highest y value on that graph? Infinity. Nice job. Okay, so far we knocked 2 off, and that wasn't that bad. Intercepts. Let's start with the x-intercepts first. Do I have any? What'd you say? You're right. 0. And so x-intercept, I'm going to write that as 0, 0. Do I have another intercept? Yeah, I have the y-intercept as well, which is also 0, 0. Now remember, when you write these, you need to write these in point form. Okay, so therefore we've handled the intercepts. Not too bad. Let's look at symmetry. Does this graph have x-axis symmetry? So if you fold it on the x-axis, does it fold on itself? Nope. What about y-axis? Nope. What about origin? None. So this one has no symmetry. Now we have to do continuity. Now remember, continuity means that you can walk along the graph and not like fall. So if I start walking on that graph at 0, am I ever going to fall? Okay, so the graph is continuous for its domain. Because obviously there's nothing on the left part of the graph, right, in the negatives. So how we say that is we just say the continuity is continuous for the domain. Now, if it would have breaks, then you would just say like x equals 1 is where a discontinuity is. All right, end behavior. Remember, end behavior, we look from the left and we look from the right. Okay? So what does the graph do as I move towards the left? What y value does it look like it's going to hit or approach? Let's look at the right one then. Let's look at the right behavior first. Okay, so the right part of your graph, what y value does it look like you're going to approach? Infinity. Okay, so that one's the easy one, right? Because that one's going up. This one on the left, though, is not as easy. Let's think about that. What does it look like I'm going to hit on that graph? 0. Okay, so that's going to be your end behavior. It's stopping at 0. It's not going beyond 0. It's stopping there. That's your end behavior. And then increasing and decreasing. Remember, we have intervals here. So, what do I start doing first? Do I increase or do I decrease? I increase. So I start at negative infinity, right? Where do I stop increasing? Positive infinity. It increases the whole way. So I don't even have any decreasing here. And that's all you're going to do. On every one of these problems, you're going to go through, you're going to identify the domain, the range, the intercepts, the symmetry, the continuity, the end behavior, and whether it's increasing or decreasing. Pretty straightforward? So this is the first part of your assignment. Tomorrow, you're going to do the second part. I'm going to warn you, the second part's a little tricky. Okay? And in fact, what I want you to do, I take that back, we're going to look at one more. Let's look real quick. F of x equals the absolute value of x. Sorry, I fibbed. Where do I find the absolute value? Do you remember where that symbol is? Math. Then where? Number. Then where? Abs. Math, number, abs. Okay. Okay, so domain. What can you tell me about the domain there? Okay, domain, what's the leftmost part of the graph? Negative infinity to where? To positive infinity, because I'm just going to use all the x values. See, I'm going left to right. What about the range? What's my lowest value? 0, do I include it? So 0 to infinity. Intercepts. Yep. So I've got an x-intercept at 0, 0. I've also got a y-intercept at 0, 0. Now the reason why I'm writing them as two separate ones is because if you ever get to one where it's not, or where it's actually two separate values, I want you to be able to find both of them. Okay, symmetry. What do we got for symmetry? Y-axis, because that's the one that if you fold on, it will fold over onto itself. Okay, continuity. Continuous for what? Well, it's actually continuous for everything. So you could just put continuous, or if you wanted, you could put continuous for domain, which is what we wrote on the previous one. End behavior. On the left, what do we have? The end behavior, what's it doing? Positive infinity because it's going up. What about the right? Positive infinity because it's going up. Okay, increasing and decreasing, what can you tell me? What does it start doing? decreasing. Okay? Negative infinity to 0. Nice job. You guys did great on that one. Okay? So that's what you're going to need to do. Now this is what I'm going to need you to do. Okay? We're going to start with this tomorrow. So if you want to write this down and get it done so that you don't have to worry about having this. Okay? Go ahead and get that written down, and then I'll go ahead and put up your assignment. And once you get that written down, you've got a quiz here. Okay, so here is what you can get started on. Okay, and I'll go back just in case some of you didn't get done. But this is what it is. And actually, I'm going to change that real quick. Okay, I want you to do 1 through 6 all. Okay, 1 through 6 all, and then 8 through 32, the evens. 1 through 6 all, 8 through 32 the evens, and number 40. Okay?